So in this video, I'm going to cover the different types of problems that appear on the very first practice test in Math 101. And so we're going to start here with problems 9 through 13, and in problems 9 through 13 we're asked to identify in this set of numbers which numbers are rational, irrational, and so on. So let's take a look and I'll kind of walk you through this. So question 9, which are rational numbers? Well, rational numbers are the numbers that can be represented as a fraction. So let's take a look here. This first one, 0, I can definitely represent 0 as a fraction. I write it as 0 over 1, so that is a rational number. Negative 2, I can definitely write negative 2 as a fraction. That would be negative 2 over 1, so that is also a rational number. A mixed number, I could change that mixed number into a fraction, so that's also a rational number. Pi, now pi is a non-terminating decimal number, which means it goes on forever, and there's also no pattern to that. If there isn't a pattern and it goes on forever, I cannot write that as a fraction, so pi is not a rational number. 9.62, well, I can certainly write that as a fraction, because if I read that, actually the value of that number, that is 9 and 62 hundredths. So that's really no different than 1 3/4. So 9.62, I can write that as a fraction. The square root of 25, well, the square root of 25 is actually a 5, and that's just a regular whole number, so I can write that as a fraction. So the square root of 25 is also a rational number. 4, I can write that as a fraction, so that's also a rational number. The square root of 3, I won't be able to write the square root of 3 as a fraction because that is a non-terminating, non-repeating decimal number. Okay, question 10. Which are irrational numbers? Well, the numbers that are irrational are the ones that are not rational. So that really leaves just pi and the square root of 3. Those are the only numbers I couldn't write as a fraction. So those are my irrational numbers. Question 11. Which are real numbers? Well, real numbers are all of the numbers that we're going to be working with in this class, and all of the numbers for sure in this set of numbers. So I would say all of these numbers are real numbers. All of these are real numbers. Which are integers? Well, integers are the whole numbers and their opposites. That's one way to think about it. The other way to think about it is integers are the numbers you put when you're making your number line. So if I was to make a number line, I'd have 0, 1, 2, and then on the other side, you know, negative 1, negative 2. So just when you go to make your number line, not before you've graphed anything on there, those numbers that we put on the number line, those are our integers. So let's take a look. Well, 0 is certainly an integer. Negative 2 is an integer. 1 3/4, that has a part in it, so that's not going to be an integer. The square root of 25, that is an integer. If I take the square root of 25, that's 5. So I would say that that is an integer. 4 is an integer. Square root of 3 is not an integer. And then question 13, all of these numbers in the set above are real numbers. Next problems we'll take a look at are problems 52 through 55, where we're evaluating the expression using the order of operations. And I'm actually going to do some of these problems, and then I'm going to have you pause the video player and work some of these yourself. So I'll start by doing 52. In 52, I want to follow the order of operations to evaluate this expression. And so the very first thing we do when we're doing the order of operations is we start with parentheses or absolute value. And I do have some absolute value here. So I want to first add that 4 plus 2 inside the absolute value. So I'm going to keep my absolute value bars. 4 plus 2 is 6. Plus 3 to the third. I go ahead and copy all the rest of this stuff down. Once I've got a single answer inside the absolute value, now I want to go ahead and take the absolute value of that 6. So the very next step would take the absolute value of positive 6, which still is going to stay positive 6. Remember, the absolute value is the distance a number is from 0. So any absolute value I take is always going to end up being a positive number. So I'll go ahead and write this down. So I have a positive 6 plus 3 to the third power plus 1. Okay, the next thing I want to check for is exponents, and I do have some exponents. So I have 3 to the third power, and I'll go off on some scratch work and I'll do 3 to the third power. That is 3 times 3 times 3. And so if I multiply these first two 3's together, that's going to give me 9. And then 9 times 3 is 27. So I'm going to come back over to my problem now, and I have 6 plus that 27 plus 1. And now I just have 3 numbers to add, so I'd say first 6 plus 27, that's going to give me 33, plus 1 gives me my final answer of 34. Notice as I was working this problem, I did not include any equal signs, and I kept doing one step at a time until I got down to the bottom to my final answer. Okay, now go ahead and pause your video player. I'm going to have you guys work question 53 before I do it. So pause the video right now and work through question 53. When you're done working question 53, hit play and you can see how you did. Okay, so in question 53 I have braces, brackets, and parentheses in there, and so I kind of look at this as a problem inside of a problem, and so I kind of keep working my way inside of these braces and brackets till finally I get to these parentheses, and this is where I'm going to start, is with this 8 minus 3. So I'm going to copy all the rest of the stuff down, and 8 minus 3 is going to give me 5 as my answer inside the parentheses. Okay, still working inside those brackets. I'm going to add the 5 and 5 together next. That's going to give me 10 inside the brackets. Okay, now I'm working inside the braces, still trying to get that down to an answer. So I would say a negative 10 plus a positive 4. Negative 10 plus positive 4 is going to give me negative 6. Finally, the last step to that problem is a negative 6 minus 9. Well, I can think of that as a negative 6 plus a negative 9, which would give me a negative 15. Next, we're going to take a look at question 54. In question 54, I'm going to start working this problem inside the brackets. And in the brackets here, you'll notice I have subtraction and I have this fraction, but that fraction bar is actually division. And in this particular fraction, 5 divided by 25, I can do that division. It's going to work out evenly. So that's where I'm going to start with this problem. So I'm going to copy this stuff down. And I'm going to do that division. 25 divided by 5 will give me 5, so I'm going to have 6 minus 5 inside those brackets. Okay, still working inside the brackets. 6 minus 5 is 1. Copy the rest of this stuff down. Okay, now I'm looking, I have division, addition, and multiplication. I also have an exponent, so I want to do that exponent next. And notice there's parentheses around the negative 4, so that means off here on Scratchwork that I'm going to take negative 4 times negative 4, which is going to give me a positive 16. So I'm going to go ahead and put that positive 16 in there. Okay, so I have division and multiplication. I'll do those next. 16 divided by 16 is 1. And I'm going to add to that the result of 3 times 1, which is 3. So I'm going to get for my final answer here 4. And I ran out of room, so that's why I had to put the 4 to the right. Normally I'd put that directly below. Okay? Now it's time for you to practice this idea. So pause the video player and solve question 55. And when you get done evaluating this expression, hit play to see how you did. Okay. Step 1 is to start in the brackets with this fraction, 10 divided by 2, which is 5. Copying this down. Still working inside the brackets. 4 minus 5 is going to give us negative 1. Okay. Now I'm taking a look. I do have an exponent there, and that is negative 5, but actually there's no parentheses here, so it's just the 5 that is getting squared. So if I square 5, that's going to give me 25. So this is what that'll look like. 25 divided by negative 25. Okay, let's talk about that just for a minute. When I had negative 5 squared, it's just the 5 that is getting taken to that second power. So really what I have here is I have a negative sign, and then I'm going to take 5 times 5, and so that's why I ended up with negative 25 for that answer. Okay, going back to our order of operations question, I have division and multiplication, so I will do those next. 25 divided by negative 25 is negative 1. And now if I take a look at this, I'm going to look at that as a negative 3 times a negative 1. Well, a negative 3 times a negative 1 is actually a positive 3. And so again, I'm going to go to the right here. A negative 1 plus 3 is going to give me an answer of 2. Normally I'd write that below, but I'm running out of room here. Okay, the next problem types we're going to take a look at are simplifying by using the distributive property. So I'll start by doing question 58. Here I'm asked to distribute, and I'm going to distribute this negative 3, which means I need to multiply it by both of these terms inside the set of parentheses. So I'll take a negative 3 times a positive 2, and that will give me a negative 6. And I have to include the x there since that was negative 3 times 2x. This is going to be a negative 6x. Now I'm going to take negative 3 times negative 5, which will give me a positive 15. Okay, let's take a look at question 59. I'm going to have you pause your video player here and work this problem. When you get done, hit play, and you can see how you did. So in question 59, we actually have to distribute two things. First, I'm going to distribute this negative 3. And so I'll take a negative 3 times a positive 4, which will give me negative 12. And then a negative 3 times a positive y is going to give me a negative answer. So I want to write a negative or minus 3y for that answer. Next thing I want to do is distribute this negative 2. And so I'll take a negative 2 times a positive x. That will give me negative 2x. And then a negative 2 times a negative 6 will give me a positive 12. Once we get done doing this distributive property, we want to see if we got any terms that we can combine here. In fact, any like terms that we can combine. And like terms are the terms that kind of go together. And you can see that I have a negative 12 and a positive 12 here, and I can add those together to give me 0. So that simplifies the problem. So I'm going to go ahead and add those two together to get 0, and then what I'll have left is just this, negative 3y minus 2x. All right, let's take a look at question 60 now. Starting inside the brackets, and inside the brackets I would try to do what's inside the parentheses here, but I can't add that x plus 1, so I'm going to go ahead and distribute this 3 to simplify the problem. So let's see, I'll copy this stuff down. So a 3 times an x will give me a positive 3x, and a positive 3 times 1 will give me a positive or plus 3. Now notice that 3 was not getting distributed to that negative 4, so that negative 4 is going to remain as it is. All right, let's take a look and see if I can simplify anything inside the brackets, and I can add this positive 3 and this negative 4 together. So I'll go ahead and do that. And so positive 3 plus a negative 4 will give me negative 1. Sorry, and that was a 3x there. Okay, now I can't simplify what's in the brackets anymore, so I want to now distribute this 2, and this was a subtraction symbol. Didn't show up quite as well. Anyways, that was a minus 2, so I want to distribute that negative 2 to both of these terms. So let's see, we'll have 6, then we'll have negative 2 times positive 3x would give us negative 6x, and then negative 2 times negative 1 would give us positive 2. And now I look again, I have some like terms. I have a 6 and a positive 2 that I could combine. That will give me 8. And so I would write this as 8 minus 6x. I also could have written that as negative 6x plus a positive 8. So if you switched it around, that would be fine as well. All right, now I'm going to have you pause your video player again and try question 61. When you get done working the problem, hit play and you can see how you did. Okay, question 61. We want to start in the brackets, and inside the brackets we would try to start in the parentheses, but you'll notice we don't have like terms there, so we can't add that x and 3 together. So I'm actually going to go out and I'm going to distribute this 2 to start. So that's a positive 2 that I'm distributing. So I'll copy this stuff down. We'll take a look at what we get when we distribute that 2. 2 times x would give me 2x, and 2 times positive 3 would give me a positive or plus 6. Notice the 2 is not getting distributed to that negative 5. So that negative 5 is going to remain as is. All right, still working inside the brackets. I want to combine any like terms that I have there, and I do have some like terms. I have a 6 and a negative 5 that I can combine. So I'll write all this stuff down, 2x. When I combine that 6 and that negative 5, I'm going to get a positive or plus 1. Okay, now I can't simplify any more inside the brackets because 2x and 1 are not like terms. I can't add those together. So now I want to distribute this negative 3. So I'm going to distribute this negative 3 to both of those terms. So the 8's going to stay as is. Negative 3 times a positive 2x is going to give me a negative 6x. And a negative 3 times a positive 1 is going to give me negative 3. And now I'll look to see if I can combine any more of these terms together, and I can. The 8 and the negative 3, I can combine those together. So if I add an 8 and a negative 3, that's going to give me 5. So I end up with 5 minus 6x. Again, these terms could be switched, and I could have negative 6x plus 5. That's an okay answer as well. All right, next questions we'll take a look at are 66 and 67. And here we're asked to find the value of each expression when a equals negative 3 and b equals positive 5. So I'll do 66 here to start. And so one thing that we want to do before we substitute these values in is we want to put an open set of parentheses wherever there was a variable. So with this b squared now, I want to write that as an open set of parentheses to the second power plus 2, and now where there's an a, I want to put an open set of parentheses. Then minus 3, where there was a b, I want to put an open set of parentheses. Once I get these parentheses set up, now I'll substitute the values. So we started out with b squared, so b was equal to 5, so I'll put a 5 in this set of parentheses. A was equal to negative 3, so I'll put a negative 3 inside of those set of parentheses. And finally, again, another b, so I'll put a positive 5 in there. Once I get these values substituted, now it's just simply an order of operations question. And so you'll notice I'm going to want to start with my exponent here. You could say I would start with my parentheses, but notice the parentheses are all down to a single value. When the parentheses are down to a single value, the parentheses step in the order of operations is essentially done. So I'll start with this exponent, 5 to the second power, which is 25. Copy everything else down. All right, let's take a look now. We have multiplication, and so I'm going to do the multiplication in both of these spots. So we'll start with this. If I have a positive 2 times a negative 3, that's going to end up with a negative 6. So I'm going to write that as negative or minus 6. Looking at my next multiplication, I have a negative 3 times a positive 5. Again, that's going to give me a negative answer, so I want to write this as negative or minus 15. Now I just have some subtraction to do here. So I'll say 25 minus 6, that will give me 19. And then 19 minus 15 will give me 14 for my final answer. Okay, with question 67, I'll have you pause the video player and work this question out. When you get done working it, hit play to see how you did. All right, question 67. We'll start again with some open sets of parentheses. All right, now I'm going to substitute the values. A was negative 3, B was 5, and then again A was negative 3. We'll start first with the exponents, and this is a negative 3 to the second power, and notice that's going to be a negative 3 times a negative 3 since that negative 3 is in parentheses. So I actually have this, negative 3 times negative 3, so that's going to give me a positive 9 for my result there. If you didn't put the open sets of parentheses around there, you would have made a mistake right here and written that as negative 9. So you can see the importance of putting those parentheses around whenever we're substituting for a variable. All right, rewrite the rest of the problem. Okay, 2 sets of multiplication to do. So the first one, a positive 4 times a positive 5, is going to give me a positive or plus 20. Now a negative 3 times a negative 3 is going to give me a positive or plus 9. And now I just have some addition to do. 9 plus 20 gives me 29. And then 29 plus 9 gives me 38. All right, the last questions we'll take a look at are 70 through 72, and here we're asked to translate each of these phrases. So we'll start, I'll go ahead and do 70 here. So 20 fewer than 3 times A. Well, we want to split this up into 2 parts here. So 20 fewer than, if we're going to take 20 fewer than or 20 less than, that means we're going to be subtracting 20 from something. So I want to think of this as we're going to be subtracting 20 from something. Well, what are we going to be subtracting 20 from? Well, the next thing that's written here, which is 3 times A. And so I want to write that as 3 times capital A. Go ahead and pause your video player now and try question 71. And then when you get done, hit play and see how you did. Okay, so question 71. The first thing we have written here is f quadrupled. So if I want to quadruple a number, I got to multiply it by 4. So I want to take and multiply 4 times f. And the easiest way to write that multiplication is just 4f. So let's go to the next part. That quadrupled f is going to get subtracted from 30. Well, that means we need to be subtracting this quadruple f, and we're going to subtract that from 30. Okay? Go ahead now and pause your video player again and answer question 72. When you get done, go ahead and hit play and you'll see how you did. Alright, question 72. We're asked to find the quotient of something. Well, that means division. And typically when I do my quotients, I usually write the fraction bar like this. It really organizes the work a lot better. So when I see the word quotient, I go ahead and make that fraction bar, and let's see. The first thing I see after the word quotient is A. The quotient of A. And so the first thing we see when it's written this way, the quotient of A, that means that A is going to go on the top of my quotient. Okay? So the quotient of A will be divided by, well, this fraction bar is taking care of the division, will be divided by the sum of B and C. So this is what we want to be dividing by, is this sum of B and C. So I want to put that sum in the denominator of my fraction, so B plus C. And there I have it. That is the quotient of A will be divided by the sum of B plus C.